Lions, Panthera leo, are large, muscular felines with powerful forelimbs, retractable claws, and a compact yet heavy-boned frame built for bursts of speed and crushing power. Adult males are famous for their mane, a ruff of long hair framing the face and neck, while females lack this ornament and show a sleeker profile adapted for stealth and endurance. Coat color ranges from pale buff to yellowish brown. Males are typically larger, with broader heads and heavier chests. Lions' heads are broad, their jaws powerful, and their teeth adapted to tear meat and crush bone. Socially, they are unique among big cats for forming prides, family groups that cooperate in hunting, territory defense, and rearing young. Now, let's unpack 25 fascinating facts about lions with deep explanation. Fact 1. Lions can't purr continuously like house cats. They can only make a purring-like sound while exhaling. When people compare a house cat's contented purr to the deep rumble of a lion, it's tempting to call them the same behavior. But anatomically and functionally they differ in a critical way. True continuous purring, the steady, rhythmic sound that accompanies both inhalation and exhalation in domestic cats, depends on specific vocal tract and laryngeal structures that generate a sustained oscillation as the animal breathes in and out. In small felids, the purring cats, the hyoid apparatus and soft tissues around the larynx allow that continuous bilateral airflow oscillation and muscular control. By contrast, the large roaring felids in the genus Panthera, like lions, tigers, jaguars, and leopards, evolved a laryngeal structure with modifications that enable very low frequency, high-amplitude roars rather than continuous purrs. One of the key differences is a specialized ligament and more flexible laryngeal cartilages which, together with a uniquely shaped vocal fold system, produce the resonant roar that can travel very long distances across savanna landscapes. That roar is produced by muscular control and air pressure changes during exhalation and is not the same bilateral breathing oscillation that defines a domestic cat's purr. In practical terms, this means lions will emit throat-vibrating sounds, chuffs, grunts, and purr-like chirps during close social contact, but the characteristic continuous purr, in and out, that signals contentment in a house cat is not part of the lion's vocal repertoire. This divergence likely reflects differing evolutionary pressures. Small felids benefited from low amplitude, continuous purrs for close-range social bonding and nursing. Large, social savanna cats benefited from long-range, powerful vocal signals, roars, for territory defense and group coordination. The result is two different vocal adaptations built on shared ancestral anatomy but diverged through selection for different communication challenges. Fact 2. Male lions' manes get darker with age and testosterone levels. Darker manes often signal strength and virility. The mane is one of the most striking secondary sexual characteristics among mammals. More than ornament, it's an honest signal that integrates physiology, developmental history, and environmental interaction. Research from long-term field studies and controlled observations has shown that mane development is strongly correlated with age, hormonal status, especially testosterone, and nutritional condition. Young males begin to grow fuzzier, shorter manes at sexual maturity. As they age and testosterone levels remain high, their mane hair grows longer and often becomes darker. Dark pigmentation in hair is produced by higher concentrations of melanin, and in lions that melanin production appears to correlate with endocrine factors like testosterone and with overall health. From an evolutionary perspective, this is a classic sexual selection scenario. A darker, fuller mane signals to both rival males and potential mates that the bearer has sufficient resources and physiological robustness to invest in a conspicuous ornament. For males, a dramatic mane can intimidate opponents or signal a high probability of winning fights. For females, it provides a visual cue for mate choice, often associated with genetic benefits such as parasite resistance or better territory holding capability. Importantly, mane expression is also constrained by environment. Hotter climates tend to favor shorter or lighter manes because of thermoregulatory costs. This trade-off highlights that mane darkness is condition-dependent and therefore a reliable signal. Longitudinal field data corroborate these patterns. Males with darker manes tend to have higher mating success and better competitive outcomes, though not without costs, e.g., overheating risk, higher metabolic demands. The mane thus functions as an honest advertisement, not merely vanity, shaped by competing selective forces. Fact 3. Female lions prefer males with fuller, darker manes, as it indicates good health and fertility. Sexual selection theory predicts that when females can benefit from discriminating among potential mates, they will evolve preferences for traits that honestly reflect male quality. In lions, numerous behavioral and observational studies show that female lionesses often prefer mates with fuller and darker manes. But why is this preference adaptive? First, a dark, full mane reflects several underlying biological realities: elevated testosterone during development, good nutrition, and lower parasite loads, all proxies for overall male condition. Testosterone itself is immunomodulatory. While it can promote the expression of male secondary sexual traits, it can also suppress certain immune functions, meaning that only males in genuinely good condition can sustain high testosterone and still remain healthy. Thus, a dark mane is an index trait. Hard to fake and therefore reliable. Empirical evidence from field experiments and natural observations supports this. Lionesses tend to solicit mating from darker-maned males more often, and long-term demographic studies show darker-maned males achieve higher reproductive success in many populations. Additionally, darker manes correlate with male dominance and territory quality in many contexts, which means mating with a dark-maned male increases the chance that offspring will inherit good genes and that the male will defend the pride effectively. That said, preferences are not uniform. Local conditions like heat stress, which penalizes heavy manes, and the social context, number of rival males, pride stability, modify female choice. From a proximate mechanism viewpoint, female attraction likely involves visual assessment during close interaction combined with olfactory and behavioral cues. A dark mane often co-occurs with confident behavior, larger body size, and other sensory cues that collectively guide female choice. This suite of signals implements sexual selection in a way that optimizes female fitness across variable ecological conditions. If you're enjoying this deep dive into lion biology, please hit subscribe to Animal Hidden Facts. Your subscription helps our small team keep researching, producing, and sharing thorough, fact-checked videos like this one. When you subscribe, you become part of a creative community that supports science communication, helping us dig up more surprising animal truths and keep those educational journeys coming. If you love learning about wildlife, subscribing is the single best way to help us grow and keep making content you will share with friends and family. Fact 4. Lion cubs are born with spots, similar to leopards. These help camouflage them in grass. At first glance, newborn lion cubs might look like tiny, mottled versions of adult lions. Those faint rosette-like spots and stripes are not merely vestigial decoration, they represent a crucial survival adaptation during a life stage when cubs are highly vulnerable to predation. The spotted coat pattern in many juvenile mammals, including lion cubs, serves disruptive coloration. By breaking up the outline of the cub's body, the irregular spots and pale dark contrasts make them harder to detect in dappled light, tall grasses, and the shadow-speckled environments of savannas and bushland. For a small cub lying motionless in thick vegetation, this camouflage is literally life-saving. Evolutionarily, this trait persists because neonates with better concealment survive at higher rates. Natural selection thus favors patterning retained into early ontogeny. Unlike leopards and cheetahs, where adult spotting is maintained for hunting camouflage, lion adults adopt a more uniform golden coloration that suits group hunting and social signaling. The juvenile spots fade as the cub grows and becomes more mobile and socially protected. There are also behavioral components that work with the spots. Pride and maternal strategies include hiding cubs in dense cover while the lionesses hunt and synchronizing birthing so multiple females in a pride may nurse and guard litters cooperatively. Together, morphological camouflage, spots, and social behaviors, concealment, cooperative defense, combine to maximize cub survival during a critical early window. Observers in the field often note that spotting can persist faintly into subadult stages in some individuals, a reminder of the deep developmental linkage between juvenile form and early life ecological pressures. Fact 5. Lions' tongues are so rough they can lick flesh off bone, covered in sharp papillae. If you've ever watched a lion grooming or feeding, you might notice the tongue's rasping action. Under a microscope, the dorsal surface of a lion's tongue is densely covered with conical, keratinized projections called filiform papillae. These are not taste buds, their function is mechanical. The filiform papillae are stiff, backward-pointing structures made of keratin that act much like tiny hooks. When a lion licks or tears flesh, these papillae help grip and strip tissue away from bones and hide, facilitating efficient consumption of muscle and organ tissues. In addition to aiding feeding, these structures are vital during grooming. The papillae comb through fur, removing debris, parasites, and loose hair. Anatomical and histological studies of panther or Leo tongues reveal distinct papilla patterns. Filiform papillae dominate the central dorsal area, while fungiform and vallate papillae, which contain taste receptors, are distributed in other regions. The combination allows lions to sense taste while also maintaining a powerful mechanical tool for processing carcasses. This adaptation is evolutionarily sensible. As obligate carnivores that often feed on large ungulate carcasses, lions benefit from being able to utilize as much of a prey item as possible. Efficient tissue removal improves caloric intake and reduces waste. The rough tongue is therefore an integrated biomechanical feature shaped by feeding ecology, reflecting the lion's role as an apex predator that must process large, tough food items quickly and effectively, often while under time pressure from rival scavengers or competing predators. Fact 6. Their night vision is 6 times better than humans, due to a reflective layer behind their retinas. Lions are predominantly nocturnal hunters, and their extraordinary night vision is one of the reasons they dominate the savanna after sunset. This superior visual ability stems from specialized ocular adaptations that enhance light sensitivity at low illumination levels. In lions, as in other felids, the retina contains a higher proportion of rod photoreceptor cells relative to cone cells. Rods are responsible for detecting light intensity and motion, while cones detect color and fine detail. The dense concentration of rods allows lions to detect even the faintest movements in dim light, which is crucial for stalking prey at dusk or dawn, the so-called crepuscular periods when prey species are less vigilant. But the secret doesn't end there. Behind the retina lies a specialized mirror-like membrane called the tapetum lucidum. This structure reflects light that has already passed through the retina back onto the photoreceptors, effectively giving the retina a second chance to capture photons. This reflection greatly increases sensitivity to low light, allowing lions to perceive forms, movement, and contrast where humans see only darkness. It's also what causes the characteristic eye shine when light, such as from a flashlight, hits a lion's eyes at night. The reflected glow reveals the tapetum at work. Furthermore, the shape and position of a lion's pupils also enhance night vision. Lions have round pupils rather than vertical slits, optimized for wide-field vision, helping them judge distance and detect lateral motion, essential during a chase. Their cornea and lens are larger relative to eye size than in humans, allowing more light to enter. Combined, these adaptations enable lions to operate efficiently under starlight conditions where human vision becomes nearly useless. Evolution favored these traits because lions evolved as ambush predators in environments where moonlight or twilight conditions provided enough illumination to exploit prey vulnerability. Hunting success at night also helps avoid the day's heat, conserving energy and reducing water loss, an elegant example of physiological adaptation meeting ecological need. Fact 7. Lions can sprint up to 80 kilometers per hour, 50 miles per hour, but only for a few seconds due to overheating. At first glance, 80 kilometers per hour sounds astonishing, almost as fast as a racehorse, but the truth reveals fascinating trade-offs in lion physiology. Lions are power sprinters, not endurance runners. Their musculoskeletal system is optimized for explosive bursts of acceleration rather than sustained high-speed chases. Their long, muscular forelimbs and massive shoulders store elastic energy for quick propulsion, while their flexible spine acts like a spring, flexing and extending with each stride. However, this design comes at a cost. These same adaptations that deliver raw power also generate intense metabolic heat during exertion. When a lion sprints, its large muscle mass rapidly converts stored glycogen into energy via anaerobic metabolism, a process that produces lactic acid and generates heat faster than the body can dissipate it. Because lions have relatively low surface area to volume ratios, being large, compact animals, they retain heat efficiently but lose it poorly. As a result, after just 5 to 8 seconds of full sprint, their body temperature can rise dangerously, risking hypothermia. That's why lions usually rely on stealth and proximity. They creep within about 20 to 30 meters of prey before launching a short, powerful charge. The speed is decisive, not sustained, a sprint to deliver one well-timed ambush strike. Evolution has balanced this limitation with behavioral strategies. Lions often hunt during cooler times, dusk, dawn, or night, when lower ambient temperatures allow slightly longer exertion before overheating. They also rest extensively between hunts, sleeping up to 20 hours daily to conserve energy. The lion's speed, while brief, is an engineering marvel of muscular design, showing how evolution fine-tuned anatomy for maximum lethality in a short time window. Every successful sprint encapsulates the principle of trade-offs: raw speed versus thermal endurance, nature's constant balancing act between performance and survival. Fact 8. A lion's roar can reach 114 decibels, louder than a rock concert, and can be heard up to 8 kilometers, 5 miles, away. Few natural sounds evoke more awe than a lion's roar echoing across the plains. It's not just dramatic, it's functional biology at its loudest. The roar serves as a long-distance communication tool, advertising territory ownership, reinforcing social bonds within a pride, and deterring rival males. The biomechanics behind this extraordinary sound involve a combination of anatomical specialization and evolutionary refinement. At the core of this capability lies the larynx, or voice box. In lions, the vocal folds are exceptionally large and shaped like square cross-sections rather than the typical triangular shape seen in smaller mammals. This design enables greater vibration amplitude with less lung pressure, producing very low-frequency sound waves that carry over long distances. The tissue composition is also unique. Elastic fibers in the vocal folds allow them to oscillate efficiently without damage despite intense use. The average fundamental frequency of a lion's roar is around 114 decibels measured at 1 meter, roughly equivalent to a chainsaw or a jet engine heard from 100 feet away. From an acoustic standpoint, the lion's roar contains a wide range of frequencies, from deep subsonic rumbles to sharp growling overtones. The lower frequencies travel farther and penetrate vegetation more effectively, making the roar an ideal long-distance broadcast in open savannas. Studies show that lions can recognize individual roars, assessing not only identity but also the number of individuals roaring, critical for territorial decision-making. Coalitions of males often roar together to amplify their apparent size and strength, an auditory illusion that can discourage rivals from intruding. Roaring also plays a role in social cohesion. Within prides, synchronized roaring sessions serve as roll calls, allowing members to locate one another over distances. Lionesses often respond to male roars with shorter calls, coordinating movement or signaling readiness to regroup. The roar, then, is both a weapon of intimidation and a glue of social unity, an evolved instrument of both warfare and family life, echoing across the night to maintain the delicate balance of power in the wild. Fact 9. Lions are the only truly social cats, living in structured prides led by females, not males. Unlike tigers, leopards, or jaguars, all solitary hunters, lions defy the feline stereotype through complex social organization. Their pride system represents one of the most advanced forms of social structure among carnivores. Typically, a pride consists of several related females, their offspring, and a coalition of one to several adult males who hold tenure for a few years. The fascinating part is that leadership and daily coordination come from the lionesses, not the males. The evolutionary roots of lion sociality lie in cooperation. Living in groups allows lions to defend territory and large prey carcasses against scavengers like hyenas, leopards, and wild dogs. Females, who are often sisters or cousins, cooperate in hunting, nursing, and cub protection, behaviors driven by kin selection. By helping relatives, a lioness indirectly passes on shared genes, boosting inclusive fitness. The social bonds among lionesses are reinforced through grooming, vocalizations, and physical closeness. These relationships often last a lifetime. Male lions, by contrast, are transient, They form coalitions to take over prides and defend them for a few years before being ousted. Their role centers on protection and reproduction rather than governance. This matriarchal structure ensures continuity. Even as males come and go, the female lineage persists across generations. Social life also enhances ecological efficiency. Cooperative hunting allows prides to take down larger prey such as buffalo and zebra, maximizing energy returns for group feeding. At the same time, shared cub-rearing duties improve survival odds in harsh environments. Lions' social evolution, therefore, reflects a balance between cooperative benefits and reproductive competition, a model often compared to primate societies. In this sense, lions are not just apex predators but social strategists, showing that teamwork, even among top carnivores, is a winning evolutionary formula. Fact 10. Lionesses do 85 to 90% of the hunting, while males defend territory and cubs. This gendered division of labor in lions is one of the most iconic aspects of their behavior, yet it's often misunderstood. While it's true that lionesses perform the majority of hunting, the reason isn't that males are lazy or incapable. It's about specialization and role optimization within the pride. Females are generally lighter, more agile, and possess greater endurance, making them better suited for cooperative stalking and ambushing prey. Their social coordination and silent teamwork enable hunts that rely on stealth and precise timing rather than brute force. Lionesses usually hunt in coordinated groups, positioning themselves strategically, some circling downwind, others driving prey toward waiting ambushers. This behavior demonstrates advanced communication and spatial awareness, often involving subtle tail and ear signals. Once prey is down, the males often arrive first to eat, but their contribution lies elsewhere: defense. Male lions are larger, heavier, and equipped with massive neck muscles and manes that serve as both protection and intimidation. Their presence deters hyenas and rival males from stealing kills, and they patrol territorial boundaries to prevent takeovers. From an energetic standpoint, this arrangement makes sense. Males expend huge amounts of energy maintaining dominance and territory, engaging in fights that can be lethal. Because their tenure is short, averaging 2 to 3 years, investing energy in constant hunting would reduce their ability to protect the pride and sire offspring. Females, with longer lifespans within the pride, benefit more directly from successful hunts. This division exemplifies an evolutionary compromise that enhances group survival. Females ensure food security, males ensure safety and genetic continuity. Studies using GPS and motion sensors have shown that while females hunt nightly, males' activity peaks around territorial patrols and confrontations, confirming that both sexes work tirelessly, just in different arenas of survival. Fact 11. Male coalitions, groups of 2 to 6 males, are often brothers who cooperate to take over prides. The image of a lone male lion roaming the savannah is iconic, but in reality, successful males rarely operate alone. Most dominant males form coalitions, alliances that can include brothers, half-brothers, or even unrelated individuals who bond over shared goals, survival and reproduction. The biology behind this cooperation is deeply rooted in evolutionary and social dynamics. In most ecosystems, lions face a brutal challenge. Taking over a pride means ousting resident males, often in violent combat. A single male attempting such a coup is at a severe disadvantage. Rival males may outnumber or outmatch him. But a coalition changes the equation. Working together, 2 to 6 males can coordinate attacks, share patrol duties, and collectively guard multiple prides. These alliances dramatically increase their chances of successful takeovers and long-term pride control. When the coalition is made up of related males, typically brothers from the same natal pride, the benefits are amplified through kin selection. Even if not all members mate directly, helping a brother sire cub still passes on shared genes. In some cases, coalitions form between unrelated males, but such bonds are usually weaker and shorter-lived. Kinship provides a more stable foundation for long-term cooperation. Studies in the Serengeti and Masai Mara have revealed fascinating coalition hierarchies. Within these groups, there's often a dominant male who secures most matings, while subordinates assist in defense and share feeding rights. However, subordinates aren't without benefit. When the dominant male tires or is killed, they may inherit his position. Genetic studies confirm that even subordinate males occasionally sire cubs, indicating flexible reproductive sharing. Coalition life also reshapes lion politics. Large coalitions can dominate vast territories with multiple prides, leading to higher genetic influence over the population. The famous Mapogo Coalition of South Africa's Sabi Sands Reserve, for example, once controlled an area over 170 square kilometers, reigning over several prides for years. Their story, dramatic, ruthless, and deeply strategic, shows that in a lion world, brotherhood isn't just emotional, it's evolutionary warfare. Fact 12. When males take over a pride, they often kill cubs not sired by them, to bring females back into heat. This behavior may seem horrifying to human eyes, but in biological terms, infanticide is a logical, though brutal, reproductive strategy. When new males overthrow the previous pride leaders, they inherit the pride's females, but not the cubs fathered by their predecessors. Those cubs, still dependent on their mothers, block the lionesses from entering estrus, the period of fertility, because nursing suppresses ovulation through hormonal feedback mechanisms. From the new male's perspective, time is precious. Their control over the pride usually lasts only 2 to 3 years, meaning every breeding opportunity counts. By killing the existing cubs, the males terminate the hormonal suppression, triggering females to return to heat within a few weeks. This allows the males to quickly sire their own offspring before they are eventually displaced by another coalition. It's a ruthless form of reproductive optimization, observed not just in lions but across species like langurs and bears. For the females, it's an evolutionary tragedy, but also an expected risk. Interestingly, lionesses have evolved counter-strategies to protect their offspring. Some may attempt to hide cubs during the takeover period, while others engage in pseudoestrus, mating with the incoming males even when not fertile to confuse paternity and reduce the likelihood of infanticide. From a population ecology standpoint, infanticide plays a paradoxical role. It keeps pride demographics dynamic and prevents stagnation of genetic lines, ensuring that only dominant, competitive males propagate genes. Over evolutionary timescales, this behavior reinforces sexual selection pressures that maintain the species' vitality. In a grim but effective way, the killing of cubs becomes part of the cycle of renewal that defines lion social evolution, a harsh reminder that nature's balance is not moral, but functional. Fact 13. Lions greet each other by head rubbing, called nuzzling. It spreads the group scent. While roars might dominate the night, a lion's most intimate form of communication happens in silence. When two lions rub heads or necks together, a behavior known as nuzzling or head rubbing, they're not merely showing affection. This gesture plays a vital biological and social role. It reinforces bonds, exchanges chemical information, and unifies the pride through shared scent identity. Each lion's scent carries unique chemical cues derived from glandular secretions located around the face, neck, and mouth. When lions rub against one another, they transfer these pheromonal compounds, effectively updating the pride's olfactory signature. This shared scent functions like a group ID card, distinguishing pride members from outsiders. In the dense world of overlapping territories, this is crucial. Lions can recognize family members even in darkness or after long separations through smell alone. Behavioral ethologists studying pride interactions note that head rubbing often occurs after separations, hunts, or conflicts, functioning as a reconciliation gesture. It's commonly initiated by lionesses or subadults, signaling submission, trust, or affiliation. In coalitions of males, nuzzling helps maintain cooperation and reduce aggression among dominant partners, stabilizing alliances that might otherwise fracture under testosterone-driven tension. Neuroscientifically, this tactile interaction triggers the release of oxytocin, the same bonding hormone found in humans, fostering calmness and reinforcing social cohesion. It's a vivid example of social neurobiology in action, where physical contact underpins emotional regulation and cooperation. The act of nuzzling, then, is more than a tender moment. It's a biochemical handshake that keeps the pride functioning as a coordinated, trusting unit. In short, the pride that rubs together, stays together. Fact 14. Lions are surprisingly lazy, sleeping up to 20 hours per day. To the casual observer, lions may seem indulgently lazy, sprawled in the shade for most of the day. But this apparent lethargy is a finely tuned energy conservation strategy dictated by both physiology and environment. Lions are apex predators with short, intense bursts of activity, hunting, fighting, and mating, followed by long recovery periods. These high-energy tasks rely on anaerobic metabolism, which consumes glycogen and generates lactic acid, requiring extended rest to clear and restore muscle energy reserves. In the African savanna, temperatures can exceed 35 degrees Celsius (95 degrees Fahrenheit), and lions, with their thick fur and large bodies, have limited means of thermoregulation. Prolonged activity during the day would risk overheating and dehydration. By resting through the heat and becoming active at dusk, lions align their behavior with thermoregulatory efficiency, a form of behavioral homeostasis. Studies of free-ranging lions equipped with activity sensors show distinct circadian rhythms. Most movement and hunting occur between sunset and sunrise. During daylight, metabolic rate and heart activity drop dramatically, conserving vital energy stores. This rest strategy also reduces conflict risk, since fights and hunts are energetically costly and potentially injurious. Minimizing unnecessary exertion preserves longevity and dominant stability. Moreover, lazy doesn't mean inactive. Even during rest, lions engage in subtle forms of social maintenance: grooming, nuzzling, cub care, and vigilance. In ecology, such behavior is classified as energy-efficient vigilance, conserving strength while maintaining group cohesion and awareness. So, when you see a pride lounging under an acacia tree, it's not idleness but strategic patience, a behavioral masterpiece evolved for maximum survival in a resource-scarce ecosystem. Fact 15. They hunt mostly at night, using teamwork and stealth rather than speed. Nighttime transforms the savanna into the lion's kingdom. Under moonlight, their superior night vision gives them an enormous advantage over prey, which rely heavily on sight for predator detection. But lions' success doesn't come from sheer power, it's the result of finely honed team coordination and behavioral strategy. A typical hunt begins with lionesses spreading out in a semicircle formation, silently stalking downwind of a herd. They communicate through subtle body language, tail flicks, head turns, and ear positions, cues that coordinate movement without alerting prey. Each lioness has a role. Some act as drivers, pushing prey toward others who lie in ambush. Once within 30 meters, they break cover in unison, launching a rapid, synchronized charge that overwhelms their target's ability to escape. This cooperative hunting behavior, rare among cats, maximizes efficiency in capturing large prey such as zebras, wildebeests, or buffaloes. Data from GPS-collared prides show that hunts involving 3 or more lionesses have a success rate up to 3 times higher than solo attempts. Males occasionally assist, especially with large or dangerous prey, but their main contribution comes afterward, securing the kill from scavengers. Stealth is key. Lions rely on the element of surprise rather than prolonged chases, which would cause overheating, as discussed earlier. Their padded paws allow silent movement, and their coat color blends perfectly with the dry grass. Their respiratory and muscular systems are tuned for explosive bursts rather than endurance, meaning every hunt is a gamble, one that must succeed after days of waiting. In essence, lions are tactical hunters, combining sensory superiority, silent communication, and calculated patience. Their nighttime strategy showcases nature's brilliance, evolution favoring cooperation and precision over reckless pursuit. Fact 16. Lions once lived in Europe and North America, not just Africa. Fossils show they ranged across continents. When people imagine lions, they picture the golden savannas of Africa. But paleontological evidence reveals a far broader story, one of global conquest and adaptation. During the Pleistocene epoch, roughly 2 million to 10,000 years ago, lions roamed vast regions of Europe, Asia, and even the Americas. These were the so-called Panthera leospelea, the Eurasian cave lion, and Panthera atrox, the American lion, both close relatives of the modern African lion. Fossilized remains, cave paintings, and preserved bones have been found from the British Isles to Alaska, proving lions once dominated the northern hemisphere. The Eurasian cave lion, for example, was one of the largest cats ever known, standing nearly 1.2 meters tall at the shoulder and weighing over 300 kilograms. Cave art discovered in France and Germany, particularly in the Chauvet Cave, depicts groups of these lions hunting or interacting, suggesting early humans not only coexisted with them but studied their behavior. These illustrations are among the oldest animal depictions known, dating back 30,000 years, showing that lions were once integral to Europe's Ice Age ecosystems. Across the Atlantic, the American lion, Panthera atrox, slightly larger still, prowled from Alaska to Peru. Genetic analysis of fossils indicates that P. atrox and P. spalea diverged from a common ancestor about 340,000 years ago, possibly migrating across the Bering Land Bridge. Their extinction, likely due to climate shifts and the decline of megafauna prey, marked the end of lions' presence in the New World. From a biogeographic perspective, lions' wide distribution highlights their adaptive flexibility, thriving in tundra, forest, and steppe habitats as easily as today's savannas. Their eventual retreat to Africa and small pockets of Asia was shaped not by evolutionary inferiority but by environmental compression and human expansion. So next time someone calls the lion king of the jungle, remember, it was once emperor of continents, an apex predator from Spain to Siberia, whose legacy still sleeps beneath layers of Ice Age dust. Fact 17. The Barbary lion of North Africa was the largest subspecies, with males weighing up to 270 kilograms, 600 pounds. The Barbary lion, Panthera leo, once found in the Atlas Mountains of Morocco and Algeria, was the stuff of legend, massive, dark-maned, and awe-inspiring. Historical accounts and preserved specimens suggest males averaged between 220 and 270 kilograms, 480 to 600 pounds, making them among the heaviest lions ever recorded. Their thick, luxuriant manes, often extending over the shoulders and belly, evolved as protection against mountain cold, unlike the short, lighter manes of savanna lions. For centuries, Barbary lions occupied rugged highlands and cedar forests, preying on red deer, boar, and wild cattle. Their isolation from sub-Saharan populations, divided by the Sahara Desert, led to distinct genetic and morphological traits. This separation is a classic case of allopatric differentiation, where geographic barriers drive evolutionary divergence. Tragically, by the early 20th century, the Barbary lion was driven to extinction in the wild, hunted relentlessly by European colonists and local rulers who viewed them as both threats and trophies. The last confirmed wild Barbary lion was killed in Morocco's Atlas Mountains in 1942, though unverified sightings persisted into the 1960s. Modern genetic research has revealed a hopeful twist. Analysis of lions kept in royal menageries and zoos across Europe uncovered descendants of the Barbary lion, particularly among lions once gifted to the Moroccan royal family. DNA sequencing suggests some zoo lions retain partial Barbary ancestry, though no pure individuals are known. Conservation programs have since aimed to selectively breed lions with these genetic markers to reconstruct the Barbary genotype, not to resurrect the subspecies exactly but to preserve its heritage within a broader African lion gene pool. The Barbary lion story is more than a tale of loss, it's a mirror of human impact and scientific redemption. It reminds us that even apex predators are vulnerable when isolation meets human ambition, and that conservation genetics may be our final bridge to reconnect the past with the present. Fact 18. Lions used to live in Greece, with references found in ancient Greek and Roman texts. Few people realize that lions once roamed the lands of myth and marble, ancient Greece. Historical records from the 5th and 6th centuries BCE describe lions inhabiting the Balkan Peninsula, Macedonia, and northern Greece. Herodotus, Aristotle, and later Roman naturalists wrote about lions attacking horses and livestock, particularly along the Macedonian plains. In fact, Herodotus detailed Persian army routes being attacked by lions as they crossed Thrace around 480 BCE, compelling evidence that wild lions still thrived in southeastern Europe at that time. Archaeological findings corroborate these accounts. Ancient Greek coins, mosaics, and sculptures, such as those from Mycenae, depict lions prominently, symbolizing power and divinity. The Lion Gate of Mycenae, built around 1250 BCE, is one of the oldest stone reliefs in Europe, representing lions as royal guardians. These artistic representations weren't purely symbolic, they were drawn from life. Biologically, these European lions were likely part of the Eurasian subspecies, Panthera leo-europea, which shared ancestry with the later Barbary lion. Their decline coincided with human expansion, deforestation, and overhunting, particularly during the Roman Empire's rise, when lions were captured for gladiatorial arenas. By the 1st century CE, wild lions had vanished from Greece and were rapidly declining across the Middle East. This ancient coexistence between humans and lions influenced mythology deeply. Heroes like Hercules and Heracles famously wore lion skins, symbolizing strength. The Nemean lion, slain in one of Hercules' 12 labors, was likely inspired by real lions of the Greek and Anatolian wilderness. Thus, the lion's disappearance from Europe wasn't merely ecological, it was cultural extinction too. The same species that once roared through Greek forests became mythologized in art and legend after humans erased it from reality. In a sense, every depiction of a lion on an ancient shield or temple frieze is both a tribute and a tombstone to Europe's lost king of beasts. Fact 19. Asian lions, and India's Gir forest, are smaller, with shorter manes and a distinctive belly fold. Today, the last bastion of the Asian lion, Panthera leo persica, survives in a single protected area, the Gir forest of Gujarat, India. Once ranging across the Middle East into northern India, this subspecies suffered catastrophic decline due to hunting, habitat loss, and competition with humans. By the early 20th century, fewer than 20 individuals remained. Thanks to concerted conservation, the population now exceeds 600, but it remains genetically bottlenecked. All modern Asian lions descend from that tiny remnant. Morphologically, Asian lions differ subtly yet distinctly from their African relatives. They are generally smaller, with adult males weighing 160 to 190 kilograms, 350 to 420 pounds. Their manes are shorter and sparser, leaving their ears visible, likely an adaptation to India's hot climate. The most distinctive feature, however, is the longitudinal belly fold, a loose flap of skin running along the abdomen, absent in most African lions. Scientists use this physical marker to identify individuals in the field. Behaviorally, Asian lions are less social than their African cousins. While African prides can have a dozen or more females, Asiatic prides tend to be smaller, often consisting of one male and 2 to 5 lionesses. This likely reflects differences in prey availability and habitat density. They primarily hunt smaller ungulates such as cheetal deer, nilgai, and wild boar rather than massive African buffalo or zebra. Conservation biology treats the Gir lion as a symbol of successful species recovery, but also a warning. The population's genetic uniformity makes it vulnerable to disease outbreaks and environmental change. Efforts are underway to establish a second wild population in India's Kuno National Park to safeguard against catastrophic loss. In the grand scheme of evolution, the Asian lion stands as both survivor and relic, a living link to the once vast range of lions that ruled from Greece to Bengal. Its quiet endurance in Gir is a testament to resilience, adaptation, and the power of conservation when science meets commitment. Fact 20. Lions can interbreed with tigers, producing ligers, lion father, or tigons, tiger father, both rare hybrids. Among nature's most fascinating and controversial experiments are the hybrids between lions and tigers. When a male lion mates with a female tiger, the result is a liger, the largest hybrid cat known, capable of exceeding 400 kilograms, 880 pounds. The reverse pairing, a male tiger with a female lion, produces a tigon, generally smaller and more tiger-like in appearance. These hybrids are not found in the wild but arise under human-managed conditions, mainly in captivity, where the two species are kept in proximity. Biologically, lions and tigers diverged from a common ancestor roughly 3 million years ago, yet their genomes remain compatible enough to produce viable offspring. However, ligers and tigons are typically sterile, a phenomenon explained by Haldane's rule, which predicts hybrid infertility in one sex, often the heterogametic sex, males and mammals, due to chromosomal incompatibilities. The liger's enormous size results from a genomic imprinting mismatch. In lions, paternal genes promote growth to ensure cub competitiveness within a pride, while maternal genes restrain it to conserve resources across litters. In tigers, this parent-offspring tug-of-war evolved differently due to their solitary nature. When a lion father's growth-promoting genes meet a tiger mother's relatively unrestricted womb environment, the result is unchecked growth, hence the liger's gigantic size. Tigons, conversely, inherit opposing constraints and are smaller, sometimes even dwarf-like. While visually spectacular, ligers and tigons raise ethical and ecological concerns. They do not occur naturally, and breeding them serves no conservation purpose, as they cannot be reintroduced to the wild. Furthermore, they often suffer health complications such as organ strain, spinal issues, and fertility defects. Nonetheless, hybrids illustrate a powerful lesson in comparative genetics and evolutionary divergence, showing how even closely related species can drift behaviorally and ecologically while retaining a shared ancestral blueprint. The liger, a creature both awe-inspiring and unnatural, stands as a living reminder that nature's balance depends not only on biological possibility, but on ecological purpose. Fact 21. Lions recognize individuals by their roars, similar to how humans recognize voices. In the vast African savanna, where prides can be separated by kilometers, sound becomes the most reliable messenger of identity. The lion's roar, a thunderous vibration reaching up to 114 decibels, is not merely a display of dominance, it's a vocal fingerprint. Each lion possesses a unique roar pattern, distinguished by pitch, rhythm, and frequency modulation, allowing others to recognize exactly who is calling. Scientific studies using bioacoustics analysis have shown that lions can differentiate familiar individuals from strangers purely by listening to recorded roars. When researchers played recordings of known pride members, lions reacted calmly or approached curiously. But when the same recordings were swapped for unfamiliar roars, lions became visibly tense, pacing, growling, and sometimes roaring back in defense. This reaction demonstrates a sophisticated level of auditory recognition and memory. Anatomically, this ability is supported by a specialized larynx and vocal fold structure. Lions have a square-shaped vocal fold ligament, unlike most mammals, which amplifies their low-frequency resonance. These frequencies travel farther through dense vegetation and open plains, functioning like a biological radio signal that carries identity, emotion, and intent. In evolutionary terms, this trait likely arose from the lion's social structure. Being the only truly social big cat, lions depend on vocal communication to coordinate pride movements, defend territories, and maintain group cohesion. Recognizing roars helps avoid unnecessary conflict and strengthens familial bonds, particularly among females who rely on each other for cub rearing. So, when you hear that powerful roar echoing through the wilderness, remember, it's not random noise. It's a message, an introduction, and sometimes, a warning. Each roar is as distinctive as a human name being called across the wind, the sound of identity in one of nature's grandest orchestras. Fact 22. They use over 30 vocalizations, including grunts, moans, growls, and even a cough call. Lions are remarkably vocal animals, and while their roar gets all the fame, it's only one note in a complex acoustic language of over 30 distinct sounds. Each tone conveys context, emotion, or intent, creating a nuanced social code that rivals that of primates in complexity. The grunt is among the most common sounds, a low, throaty exhalation used during friendly encounters, often when pride members greet one another. Moans serve a different role. They're softer, drawn-out calls used to maintain contact, especially between mothers and cubs when visibility is poor. Growls and snarls express aggression or defense, often during feeding or territorial disputes, and serve as auditory warnings to maintain hierarchy. But one of the most fascinating lion sounds is the coughing call, a short, chuffing exhalation that functions like a roll call. It's often used during hunts or territorial patrols to keep track of pride members. Unlike the full roar, which can travel kilometers, this call is localized and discreet, perfect for close coordination without alerting prey or rival lions. Acousticians studying lion communication have found that these vocalizations share structural similarities with human phonetics. Each sound is shaped by airflow, vocal fold tension, and laryngeal muscle control, factors that determine pitch, volume, and emotional tone. This adaptability allows lions to modulate not just what they say, but how they say it, distinguishing reassurance from aggression or curiosity from command. In ecological terms, this rich vocal repertoire enables social flexibility, essential for survival in dynamic environments. Whether calling to cubs hidden in the brush, coordinating ambushes under moonlight, or warning rivals of their strength, lions use their voices as tools of connection and control. It's easy to think of them as silent predators, but in reality, lions are among the most expressive communicators in the animal kingdom, masters of a language written not with words, but with sound waves of power and precision. Fact 23. Lionesses coordinate ambushes using subtle tail and ear signals, a sign of complex communication. Hunting in the African wilderness is an art form, and for lionesses, it's one choreographed with quiet grace and tactical precision. When stalking prey, they rely not on vocal signals but on body language, using ear flicks, tail twitches, and head movements to coordinate with remarkable synchronicity. A slight flick of the tail can signal readiness or alert the group to danger. Ear position often communicates focus direction. When the lead lioness angles her ears toward a prey animal, the others instantly adjust their approach. Sometimes, even a subtle shoulder shift can cue partners to flank or wait. These signals are nearly invisible to prey animals yet perfectly readable to pride members, showcasing an extraordinary form of nonverbal communication that has evolved through millions of years of cooperative hunting. Field observations by ethologists like George Schaller revealed that lionesses assume distinct roles during hunts. The central lioness often initiates the stalk, drawing prey attention, while flankers move in semicircles to block escape routes. This strategy relies on spatial awareness and mutual understanding, skills rarely seen outside human or dolphin societies. From a neurological standpoint, such coordination reflects a high degree of social intelligence. Lions must remember not only their own position but also the intentions and movement patterns of others, essentially a form of theory of mind. This capacity suggests that lions understand, at least implicitly, the perspectives and reactions of their teammates. Cooperative hunting offers evolutionary advantages. By pooling effort, lions can take down larger prey like buffalo or giraffes, ensuring greater food security for the pride. But its success hinges entirely on communication without sound, a shared language of motion. Every twitch of the tail, every frozen pause in tall grass, is a signal and a silent dialogue of survival, one that makes lionesses not just hunters, but tacticians of the natural world. If you're fascinated by the hidden intelligence and communication of lions, imagine what other mysteries lie beneath nature's surface. At Animal Hidden Facts, we dive deep into the science behind wildlife behavior, from evolutionary biology to real-world conservation. Subscribe now and become part of our growing community of curious explorers. Your support helps us produce high-quality, research-based content that keeps these stories alive and brings the wonders of nature closer to everyone. Together, we can keep curiosity roaring. Fact 24. Lions can count rival roars. Studies show they assess how many opponents they face before deciding to fight. One of the most remarkable demonstrations of lion intelligence comes from their ability to numerically assess threats through sound alone. In groundbreaking experiments conducted in Tanzania's Serengeti, researchers played recordings of different numbers of roars to pride members. The lions responded cautiously to one or two roars, but when the recording simulated 3 or more intruders, they often retreated, even without visual confirmation. This behavior indicates that lions possess numerical cognition, the ability to estimate quantity based on auditory input. Such cognitive skill is rare in the animal kingdom, mostly documented in primates, dolphins, and certain birds. For lions, it serves a critical survival function. Engaging a stronger coalition can lead to severe injury or death, while retreating strategically preserves the pride's strength and cub safety. This decision-making process shows that lions use cost-benefit analysis, a cognitive framework that balances risk against reward. The neural processing behind it likely involves the parietal cortex, associated with spatial and quantitative reasoning. By mentally counting roars, lions gauge not only number but also proximity, direction, and confidence, all vital cues in territorial defense. This form of acoustic assessment exemplifies what biologists call referential thinking, the ability to interpret sounds as abstract representations of external conditions. Lions aren't just reacting to noise, they're decoding it, interpreting meaning, and forming strategies. In evolutionary terms, this ability underscores why lions became dominant among large carnivores. Their intelligence doesn't lie merely in brute strength but in strategic restraint, knowing when to fight and when to wait. In the savannah, survival isn't just about being powerful, it's about being perceptive. And in that arena, lions reign supreme. Fact 25. Lions show cooperative parenting. Females synchronize births and nurse each other's cubs. In most carnivores, mothers raise their young alone. Lions, however, evolved an extraordinary system of communal motherhood, where females within a pride give birth within weeks of each other and collectively rear their cubs. This synchronization is not accidental, it's hormonally influenced and socially reinforced, ensuring that cubs are born into a supportive nursery network rather than isolation. When cubs are small, lionesses take turns nursing not just their own offspring, but those of other females, a behavior known as allonursing. Research shows that this cooperative strategy increases survival rates, as cubs have multiple caregivers available for protection and feeding. It also helps distribute energy costs more evenly among females, allowing the pride to maintain overall health and stability. This system relies on strong kin selection. Most pride females are closely related, sisters, mothers, or cousins, meaning that helping another's cubs still passes shared genes forward. Evolutionary biologist W.D. Hamilton described this concept as inclusive fitness, where altruism benefits the genetic success of a group rather than just an individual. Beyond biology, this cooperation also fosters social learning. Cubs grow up surrounded by older juveniles and adults, observing hunting techniques, social cues, and territorial behaviors. This early education accelerates their development and cements the pride's social fabric. Such intricate cooperation is rare among predators, making the lion a model for understanding social evolution. In their nursery dens, under the golden light of the savannah, lies a lesson far older than humanity: survival through unity. And that brings us to the end of our deep dive into the hidden truths of the lion, nature's social monarch. From prehistoric dominance to modern-day intelligence, every fact reminds us that lions are far more than symbols of strength. They are embodiments of cooperation, strategy, and resilience. Thank you for watching Animal Hidden Facts. If you enjoyed this exploration, don't forget to like, subscribe, and share this video. Your support helps us keep uncovering the secrets of the natural world and bringing science to life, one roar at a time. Until next time, stay curious, stay inspired, and keep the wild in your heart.